Okay, here's an example of an exponential decay problem is what we're going to be doing here. So here's the problem. Radium decays exponentially and has a half-life of 1600 years. Find a formula for the amount remaining after t years if you start with 50 milligrams, round k to 3 places. How much will remain after 250 years? When will there be 20 milligrams remaining? Okay, so since half-life has radium has a half-life of 1600 years, we know automatically that since k is equal to the natural log of 0.5 divided by time. So in this case, k is equal to the natural log of 0.5, because that's half, divided by 1600. And we're going to round k to 3 places. More than likely, it will be a number in scientific notation. So let's do that here. So turn this on, clear that up. So we do the natural log of 0.5 divided by 1600. We get negative 4.33, round of 3 places, negative 4.332 times 10 to the negative fourth. So this is negative 4.332 times 10 to the negative fourth. And that's our k. Just to make sure I check that right. Negative 4.33 times 10. Okay, good. Okay, so there's that. So therefore our equation is going to be some sort of P of t, our population. Our initial amount is 50. So it's going to be 50 e to the negative 4.332 times 10 to the negative fourth t. And there's part A. That's part A. Part B. How much will remain after 250 years? Well, how much will remain after 250 years is just when t equals 250. So this is P of 250, and this is equal to 50 e to the negative 4.332 times 10 to the negative fourth times 250. And so then we just number crunch this to get our answer. So we take 50 e, there it is, to the negative 4.332 second function comma to get the exponential, negative fourth times 250, and then close our parentheses off. Make sure you have parentheses around the whole thing for the exponential. You have 44 round to 2 places, so we have the answer, whoop, I missed it, is 44.87. So 44.87 milligrams. And that's the answer to part B. Oops. Part C we'll do over here. When will there be 20 milligrams remaining? In other words, when is 20 going to equal 50 e to the negative 4.332 times 10 to the negative fourth t? So we have to solve for t here. Okay, now anytime you have to solve for an exponential, the first thing you have to do is you have to get rid of this coefficient right here. So 20/50ths is just basically 2/5, or 0.4. You can put that as well. Equals e to the negative 4.332 times 10 to the negative fourth t. Then we're going to natural log both sides. Okay, so we have the natural log of 2/5 is equal to, these go away, so this is negative 4.332 times 10 to the negative fourth t. Then we divide by negative 4.332 times 10 to the negative fourth. Divide by negative 4.332 times 10 to the negative fourth. Scroll here a little bit. And then let's get this solution. So this one's going to be the natural log of 2 divided by 5, like so. Close up that parenthesis on that natural log, divided by negative 4.332 332, second function, comma, -4. We'll take 2,115 years, round to the nearest year. So t is equal, I already forgot it, 2,115. 2,115 years. Which makes sense, because it will take, the half-life is 1,600 years. So just to get to 25 milligrams, it's going to take 1,600 years. So to get to 20, it should take more than 1,600. In fact, it takes 2,115. So that's it. I hope this helps you out in solving radioactive decay problems involving half-life. Okay? Thank you very much.